Let's do a few inverse functions examples. We mentioned in the earlier slide that inverse functions are basically functions that undo in a function f of x. But what does that really mean, and how do we calculate it? Because that's actually the most important thing. IB will sometimes ask you, or will often ask you, please figure out what the inverse of this function f of x is. So let's start with that. Say we have a function f of x is 3x plus 5 over x minus 1. And we're asked, can you please figure out what the inverse f of that function is? We write this with the notation f to the negative 1x. That's just the simple shorthand notation for the inverse of x. To figure this out, the first thing that we're going to do is we're going to rewrite this function as an equation. Okay, so I'm going to rewrite this as y is equal to, and then just the exact same thing, 3x plus 5 over x minus 1. Nothing changes. Okay, now this is when the trick happens. We're going to take the y's and x's and we're going to switch all the y's for all the x's. Okay, so what does that leave us with? That leaves us with x is equal to 3y plus 5 over y minus 1. Now, why did we do that? We did this because now we're going to resolve this equation for y. We want it to look like the first one, y is equal to something, and that's going to be our inverse function. So I'll do the rest of this in yellow to show that we want eventually to get back to a form that looks like this. Okay, to do that, I'm going to first multiply both sides of this equation by y minus 1. What's that going to do is going to delete or cancel out those y minus 1s and get rid of that denominator from that fraction. So we end up getting x times y minus 1 is equal to 3y plus 5. Okay, let's go ahead and distribute that x term. And in fact, I'm going to keep working up here. So if we distribute that x term, we get xy minus x is equal to 3y plus 5. Now we want to solve this equation for y, so we want to bring all the y's to the same side of the equation. So I'm going to bring this 3y over here. Xy minus x minus 3y, let's erase. Boom, is equal to 5. And I'm going to bring this x over to that side of the equation, so all the y's are together and the rest are left, or everything else is left onto the other side. So what do we get? We get x to xy minus 3y is equal to 5 plus x. Last step, or almost last step, these two terms here have a y in common, so let's factor out the y. We're left with y times x minus 3 is equal to 5 plus x. So the best way, or the last step of this, is if we divide both sides of the equation by x minus 3, those two x minus 3's cancel themselves out. So we're just left with a y on the left side and a 5 plus x over x minus 3 on the right side. And this, my lovely friends, is our inverse function, f inverse. That's it. Let's do another inverse function example, because these are just too freaking fun, huh? So we've got this function f of x is equal to x squared minus 5, and we're asked to figure out what is the inverse of that function. Remember, we're going to do the exact same thing as we did earlier. We're going to rewrite this first as an equation. Y is equal to x squared minus 5. Then we are going to rewrite this by flipping the x's and the y's, or changing them. So this becomes x is equal to y squared minus 5. And now the goal is just to solve this for y. We want an equation or a function that's back in the form y is equal to something. Okay, to do this, we got to leave the y term by itself, isolated, and the best way to do that is to add 5 to both sides of these equations. That way we'll end up with an x plus 5 term and just a y squared term on the right side. The last step to this, nice and simple. Well, when I've got a squared and I want to leave it or get rid of this square and leave it just by itself, just the y, best thing to do is to take the square root of a square number, and those two will cancel out. But remember, it's an equation, so anything I do to one side, I have to do to the other. Always, always, always. That leaves us with just a y term on one side and the square root of x plus 5 on the other side. What's nice about this is that this is literally our inverse function, the square root of x plus 5. Inverse, checkmate. I know this seems simple because it actually is. Even though it seems a bit intimidating that an inverse function is all kind of wacko, doing these simple steps is always going to get you or set you up for success for the IB style problems to figure out inverse functions on an exam. Let's talk about some cool properties or neat properties for inverse functions, because these might actually help you either get some points or save a lot of time on your exams, so you can squeeze out as many points as possible and spend more time on more difficult problems that actually merit more of your investment in time. So some nice things about inverse functions is that if you know the domain and the range of a function f of x, the inverse function is literally doing the opposite, right? It's taking all the outputs from the f of x function and turning them into inputs. That literally means that the domain for the f of x function is the same thing as the range in the inverse function. Similarly, the range in the f of x function is the same thing as the domain in the f function. So oftentimes what the IB likes to do is they like to ask you in part A, figure out the inverse of some function. And you do it. Okay, great. Maybe that's worth a couple of marks. And in part B, they ask you, well, what's the domain and the range for the new inverse function? And some students really start banging their heads on the desk, and they think, oh, how am I going to figure this out? What's nice, though, is that usually they already gave you the domain for the f of x function in the problem statement. So if they give that to you and you figured out the inverse, all you have to do is literally invert the domain and the range, and there you go. So it's going to save you a few marks. We'll do a practice problem or a practice exam style question, but just keep these little tips and tricks in the back of your mind. Now, this one for me is super cool. The composite function of an f of x and its inverse is always just going to give you x. It's going to spit out just the variable. Because remember, that's basically what the inverse function is doing. It's undoing all the manipulation you did to a specific variable, basically putting you right where you started. Let's do an example. From the previous video, we knew that we had a function f of x is equal to x squared minus 5. And we figured out that the inverse of that function f of x is equal to the square root of x plus 5. If you forget or don't know what I'm talking about, go to the previous slides or the previous video. Now for this, let's put together everything we've learned so far about composite functions and stuff and create a composite function f of inverse f of x. So I'm going to take the inverse function, square root of x plus 5, and I'm going to plug it into my original f of x function. Okay, well, wherever I see an x, I'm going to write a square root of x plus 5. So let's do it like this. I see there's an x squared, so I'm going to first in parentheses put the square root of x plus 5 squared minus 5. Okay, well, something we know from, or some basic properties about exponents and square roots. If I have a square root and I'm squaring it, in fact, let's do this in yellow, those guys are going to cancel themselves out. That's really nice. So what I'm left with is an x plus 5, but then a minus 5 from the original part of the equation. Well, x plus 5 minus 5, in yellow again, those cancel, is literally just x. We've just shown that this property of inverse functions works. So if you're ever in an exam and you think you've calculated the right inverse, but you're not entirely sure, and you've got a few extra minutes maybe on a test, and you think, ooh, I'm going to double check my work, take your inverse function, create a composite function by literally just plugging it into your f of x function, and see, do you end up with x with the composite function just equaling x? If so, you got the correct inverse. If you don't, if you end up with something else, maybe you did some wrong arithmetic or some wrong algebra, and you have a little bit of a mistake. So go back and double check your work with this really cool property.